All right, let's take a look at section 6.2. We're going to continue our topics of right triangle trig. In this section, we're going to look at some applications of right triangles here in section 6.2. And we'll look at solving a right triangle. And when we say solving a triangle, we're looking at finding 6 parts. We've got to find our 3 angles and our 3 sides, right, to a triangle. We're going to solve the triangle. All right, so we've got to find all 3 lengths, all 3 angles. And if you look at an example, here we've got triangle ABC. So we've got standard lettering involved. I'm going to use capital letters. We've got angles A, angles B, and angles C. And then we've got the sides labeled with small letters. And with side opposite angle A, which you can see is this acute angle, 61.7 degrees. Side opposite angle A is what we call side A, which is one of the 2 legs of the right triangle. And of course, side B, that's an unknown. We've got another unknown in that, and that's side opposite angle B. And again, angle B is this acute angle up here. And we've got side C, which is the hypotenuse, right? The side opposite the 90-degree angle. So we've got 3 of the 6 parts given to us, right? They've got to give us half the triangle. And to solve a triangle, you've got to know at least one side to solve a triangle. All right, we can't just know all 3 angles, because if all we knew were 3 angles, all right, we couldn't establish one unique triangle from that. Right, we could make the sides any lengths we want; those angles, right, would remain unchanged. So again, we have to have a side, which is what we're given in this example. We've got one side with 2 angles. So with that said, let's solve it. Now I'm going to go ahead and start off with writing down what we're looking for. All right, so to solve the triangle, we want to know what angle, let's go ahead and write it down, angle B equals. Right, that's one of our 2 unknowns. And we want to know what side A equals. And we want to know what side B equals. Those are the 3 parts that are missing in this triangle ABC. So we know angle A, 61.7 degrees. We know angle C, 90 degrees. And we know side C, the hypotenuse, which is 106.2 units in length. Now let's go ahead and start with angle B. We've got 2 of the 3 angles given. So let's go ahead and find the 3rd angle. And to do that, we can use a little bit of geometry. Right? We know in a triangle, all 3 angles always sum to 180 degrees. So angle B is going to be 180 minus the sum of angles A and C, which is 61.7 degrees plus 90 degrees. So as we simplify down, we got 180 degrees minus 151.7 degrees, which is equal to 28.3 degrees. So here's angle B. So there's 1/3 of our solution, right, using a little bit of geometry. Now let's look at finding side A. Well, in side A, right, we're looking at the side opposite angle A. Now, to find that, all right, we're going to have to introduce some trigonometry. All right, what can we use based off what we're given? What trig function can we use to find side A? Now, what I'm going to do is use angle A because they gave me that measurement. I know it's correct. I could use angle B that I just found, but just to make sure I'm not compounding mistakes, just in case I made a little mistake and find an angle B, I always like to stick to the given information as long as I can. So let's use angle A. So if we're looking at angle A, we know that side A is the side opposite that angle. And then we also know the hypotenuse. So what relationship establishes the ratio of opposite to hypotenuse? We know that's sine's definition. So we can use the sine function. So if I ask you what's the sine of 61.7 degrees, right, you could tell me that angle measurement or that trig function. Let's go ahead and write this in here. So sine of 61.7 degrees equal to the side opposite, A, our unknown, divided by the hypotenuse, which is 106.2 units in length. So again, a little review of our definition of sine using a right triangle, right? Review back to our previous section where we established our 6 trig functions using the sides of a right triangle. Sine is opposite of hypotenuse, cosine is adjacent of hypotenuse, tangent is opposite of adjacent, and of course 3 reciprocal functions, cosecant, secant, and cotangent. Now let's go ahead and solve that. Now we've just written down what sine of 61.7 degrees is equal to. Now that allowed me to find A, so let's solve A. So to do that, I need to go ahead and multiply both sides by 106.2, right? So we can get A by itself. So that implies 106.2 times the sine of 61.7 degrees is equal to A. All right, so we found A now. So we've solved this linear equation, right? We had to get A by itself. We got rid of the coefficient, and we solved for it. Now let's go ahead, pull our calculator up. All right, let's get your TI out. I'll put it on my TI-84 app calculator. And remember, make sure your mode is in degrees. Mine is in radians. It's gone back to default mode. So I hit that mode key, make sure degree is highlighted. If not, arrow down to it, hit the enter button. And that way it knows we're dealing with degree measurements when we're looking at these trig function values. So we've got 106.2, right? 106.2 times the sine of 61.7. And again, since we're in degree mode, it knows that's degrees. So I get 93.5 rounded to the nearest tenth. So A, right, A is approximately equal to right, so A is approximately 93.5 units in length. So now we've got 2/3 of our solution. All right, we've got angle B and we've got side A, and that leaves us with our third and final unknown, which is side B. Now there's a couple ways we could get side B. All right, we could use trig in one of our trig functions, and we could use geometry now at this point because we have 2 of the 3 sides. So we could use a Pythagorean theorem, right? Square of the hypotenuse equals sum of squares of 2 legs. So we could plug in 106.2 squared equal to side A, which is 93.5 squared, plus B squared, and solve a B. Well, just to review, I'm going to go ahead and use one of my trig functions. And I'm going to use 61.7 degrees again. And now I'm going to refer to my cosine function. So cosine of 61.7 degrees is equal to the adjacent side, which is B, what I'm looking for, divided by the hypotenuse. So that'll be over 106.2. All right, now we can solve a B. So to solve a B, we got to go ahead and get rid of the coefficient. So we'll multiply both sides by 106.2. All right, and that allows us to get B isolated as we solve for B. So B is equal to 106.2 times the cosine of 61.7 degrees. So again, get our calculator out. Let's go plug that in. So 106.2 times the cosine, and we're already in degree mode on our calculator, so it knows that's degrees. I get 50.3. So 50.3 for side B, and that's 50.3 units in length. And now we've got all 6 parts, right? We've solved that triangle. So we found angle B. We found side A and side B. So all 6 parts. So we've solved a right triangle. So again, that's using some of our trig functions from section 6.1 to help us in that problem there. Use a little trig to solve it. Let's move on to a couple examples here on the next page. To solve the following right triangles, round to the nearest tenth. Standard lettering again has been used. Capital letters for the angles, small letters for the sides. Triangle here in example A gives us two sides and the angle. Right? We know we have a 90-degree angle, an angle C, and then we're given side A and side B. So again, if you're looking at the triangle, right, we can go over here and label that if we want. Let's go ahead and draw a quick picture of what we're given here. So again, we got angle A, angle B, angle C. Side A, again, 12.5 units. Side B, 18.3. So we're given the two legs of a right triangle. What we don't know, I'll put it in a different color, in blue. We don't know the hypotenuse, which is side C. And we don't know angles A and B. So that's what we got to get. We got to find out what angle A is equal to, what angle B is equal to, and side C is equal to. All right. Now, we could, if we want, we could go ahead and find side C, right, using geometry. We could use the Pythagorean theorem, right, to go get that side. So again, that's where we can go with that. Let's go ahead and do that. So let's find the third side. So I'm going to use geometry. I'm going to use the Pythagorean, right down here above it, theorem, right? We've got two of the three sides in this right triangle. So we know that C squared equals A squared plus B squared. So that implies C squared is equal to 12.5 squared plus B squared, which is 18.3 squared. And we solved that, right? We would need to take the square root of both sides to get C. So we got C squared. We need to apply the principal roots. And with that, we get C equal to the square root of 12.5 squared plus 18.3 squared, right? And we can go plug that in. Let's go put that into our calculator. So pull up our TI-84. And our second x squared key is your square root symbol. And let's put in 12.5 squared plus 18.3 squared. Right, typing that in. And with that, we get 22.2 rounded to the nearest tenth. So there's 1/3 of our solution. C, 22.2. All right, now let's go ahead and get angle A. All right, now let's find an angle measurement. Now, what trig function would allow us to find angle A? Using this given information, using sides A and B, which are the two legs of this right triangle. Well, if you remember, the definition of tangent in a right triangle involves our two legs. Involves the opposite and the adjacent. So yeah, we could use the tangent function. So what's the tangent of angle A equal to? It would be equal to the opposite side's length, 12.5, over the adjacent side's length, which is 18.3. So again, there's opposite over adjacent. Now, that's the tangent of A. We want to find A. Well, if we're going to find A, we've got to use inverse characteristics. We got to swap out this function value for A with the angle measurement. So using our inverse property, A would be equal to tan inverse of 12.5 over 18.3. So again, a little review of inverse characteristics. And let's go plug that in. Let's see what we come up with. Back to our calculator. Now remember, tan inverse is the second button, then tangent. And let's type it in. So 12.5 divided by 18.3. And out comes our angle measurement, rounded to the nearest tenth, 34.3 degrees. 34.3 degrees is angle A. All right? Now, we can stop there with our trig once we have 2 to 3 angles, which we do. We got angle C, which is 90 degrees. That was given. Right triangle. We got angle A. We know angle B. We go all 3 angles must sum to 180. So 180 degrees minus the sum of the 2 that we have, which is angle A that we just found, 34.3 degrees, plus angle C, which is 90 degrees. So let's go ahead and simplify that down. What is 34.3 plus 90? That would be what? 124.3? And what's 180 minus 124.3? That's 55.7 degrees. There's angle B. There's all 6 parts. So we solved triangle ABC. So that one involved inverse characteristics. Good example to look at. All right, let's move on to example B. Look at this triangle. Let's go ahead and get a picture. That's our first step always. Visualize what they give us. So let's go ahead and draw in a quick picture of triangle ABC. Standard lettering, capital letters for the angles. Angle C, of course, we'll let that be our 90-degree angle. Let's go ahead and label. We're given angle B. So we know this angle measurement. That is 69.3 degrees. We know the side opposite that angle is 93.4 units in length. So labeling what we don't know in this triangle is we don't know angle A, we don't know side C, and we don't know side A. So those are 3 unknowns. Angle C, what does it equal? Sorry, not angle C. Side C, what does it equal? We know angle C is 90 degrees. All right, side A, and of course angle A. So angle A, the one angle we don't know, right? And we don't know side A, we don't know side C. Now, we got 2 to 3 angles. So the first thing I'm going to do, I'm going to go ahead and find angle A. So angle A, again, all 3 must add to 180. So 180 minus the sum of the 2 that we have. So we have angle B, given to be 69.3 degrees, plus angle C, which is 90 degrees. So as we simplify that down, A is equal to 180 degrees minus, all right, what's 69.3 plus 90? That's 159.3 degrees. And what's 180 minus 159.3? That's 20.7. So 20.7 degrees is angle A. So that's 1/3 of our solution. All right, now let's go find side A. I'm going to do my work in a different color. Let's find A. Now with side A, all right, let's think about what we have in front of us. All right. Now we have in front of us angle B and side B, right? So we could, if we wanted to find side A, we could use the tangent function, right, to get that. Different ways to get there. We also have angle A given, so we could use that, but I'm going to use angle B to get to my information. So let's go ahead and do that to find A. So again, thinking about a trig function, I'm going to write down here the tangent of 69.3 degrees is equal to opposite 93.4 divided by adjacent. Opposite over adjacent. All right, and then we just got to solve A. So that would be one way. Now that's one of several ways we could go about solving A. Now since A is in the denominator, I would have to go ahead and clear out the fraction and multiply both sides by A. And that would give me A times the tangent of 69.3 degrees equal to 93.4. And then all I got to do is divide out my coefficient. Right? I can divide out both sides by the tangent of 69.3 degrees, and I have my answer. So what will A equal? So as we simplify down, we got A, again, these divide out, equal to 93.4 divided by the tangent of 69.3 degrees. So 93.4 divided by the tangent of 69.3 degrees. Let's go ahead and plug that into our TI. All right. So get your calculator out, and we'll plug that in. So pulling up our TI. All right, let's see what we come up with. So 93.4 divided by the tangent of 69.3, which we know is in degrees. I got 35.3. 35.3 for side A. Hmm? 35.3 there. So there's side A in my problem. Now we got 2/3 of our information. Now let's go ahead and get our third and final side. How about side C? Now since I know 2 to 3 sides, I'm going to use Pythagorean theorem. So Pythagorean theorem will allow me to find this third and final piece, this missing side. We know again that c squared is equal to a squared plus b squared. So c squared is equal to 35.3 squared plus b squared, which is 93.4 squared. Now we take the square root of both sides, and we'll have our value of c. All right? So principal roots. So as we take that, we got c equal to the square root, 35.3 squared, plus 93.4 squared. So let's see what we come up with our third and final piece. All right. So get our TI out, and we'll type that in. Second x squared key, there's square root, 35.3 squared, plus 93.4 squared, enter. I got 99.8. So 99.8 would be side C. All right, now we got all 6 parts. So we found the 2 sides that are missing, sides A and C, and we got angle A. So solving that triangle. All right, let's do another problem. Let's go to example here on page 4. Let's do an application. It says enclosing an area. It says Alicia is enclosing a triangular area in a corner of her fenced-in rectangular backyard for her lab dog retriever. In order for a certain tree to be included in the pen, one side needs to be 14.5 feet in length and make a 53-degree angle with the new side. How long is the new side? Round your answer to the nearest tenth of a foot. All right, so let's go ahead and draw in. Let's get a picture of this backyard that we're looking at. So we've got a rectangular fenced-in backyard. All right. All right, now let's looking at the backyard here, this fenced in. We're going to put in a triangular corner. So we need a new side here. And I'm going to draw this new side here in a different color. Let's say we put it here in this corner, left side. There's my new side. Now that's what we're looking for, the length of this new side. So we're making a triangular corner. Now, in order for a certain tree to be included in the pen, it said one side needs to be 14.5 feet and make a 53-degree angle. So I'm going to go ahead and do that. Here's my 53-degree angle. 14.5 feet for this side. So just drawing in what they gave me. Now we know in a rectangle, we know we're dealing with 4 90-degree angles. Opposite sides are parallel and congruent. But you can see a picture of our right triangle here in the corner of this backyard. So we can use right triangle trig and find the length of this new side that we've drawn here in blue. So again, x is equal to the new side. We're trying to fence in this corner. All right. Now, with that said, what trig function would allow me to find x? All right, let's go find the new side. To do that, I'm going to use cosine function. right? Cosine of 53 degrees involves my adjacent side and my hypotenuse, right? Adjacent over hypotenuse. So that allows me to find x using the given angle measurement, 53 degrees. So to solve that, let's go ahead and solve for x. So I'm going to go ahead and multiply both sides by x. We've got to clear out the fraction. So as we do that, we come up with x times the cosine of 53 degrees equal to 14.5. And then we're ready to divide out the coefficient, which is cosine of 53. So let's do our algebra. So we divide out cosine of 53 degrees on both sides. What do we come up with for x? X is equal to 14.5 divided by the cosine of 53. And get your calculator out and type that in. I'm going to let you type it in. We'll go ahead and write in the answer. We get approximately 24.1. We round to the nearest tenth of a foot. So 24.1 feet. There's the new side in this triangular corner of her backyard now. So we need to buy, 25 feet of fencing in order to make that happen. In order to include that tree in the corner, we had to make a 53-degree angle with that side that was 14.5 feet long. So again, get your picture, establish a picture, and then figure out what your unknown is, right, and go find it. So again, using right triangle trig to help us. All right, moving on, we'll look at a couple of topics we mentioned when solving right triangles. Now we're going to talk about angle of elevation and angle of depression. Angle of elevation is the angle formed between a horizontal and your line of sight. So you can see here we got a person observing an airplane up in the sky. Well, they've drawn in here the angle of elevation, right? We've got the horizontal from our sight up to the plane there, that angle. That's our angle of elevation. Now, if we were up at the plane looking down at that person, we would draw in this horizontal here, right? And our line of sight. This would be what we call the angle of depression. So the angle of depression will be congruent with the angle of elevation. If you remember from geometry, two parallel lines, which these two horizontals are parallel, and a transversal, right, line intersecting those two, forms our alternate interior angles, which are congruent. So that's one thing to make note of. Angle of depression would be the same as the angle of elevation. All right, and I'll show you a picture. There's the angle of depression for that same object. So again, the key, though, is you're drawing in your horizontal and then your line of sight, the angle between the horizontal line of sight. Make sure angle of elevation if you're looking up, or depression if you're looking down. So let's take that into an example. It says from the top of a vertical cliff 40 meters high, the angle of depression. So we're standing on the top of a vertical cliff. Angle of depression will be the horizontal from the top of that cliff down to the line of sight, whatever we're looking at. It says we're looking at an object that is level with the base of the cliff. And it said that angle of depression was 34 degrees. How far is the object from the base of the cliff, which is my unknown? Round your answer to the nearest tenth. So let's draw in a picture. So what I'm going to do is draw in my vertical cliff here. All right. So here's my vertical cliff. And it says this cliff is 40 meters in height. All right. Now, it says we have angle depression to an object that is level with the base of the cliff. So let's go ahead and draw in the base. And here's the object that's level with the base. We'll let our object be right here. All right, so here's the object. Now what we have, let's draw in the angle depression. So I'm going to draw in, now we're standing at the top of the cliff. I'm going to draw in this horizontal. And now I'm going to draw in the line of sight. So let's draw in the line of sight, and the line of sight down here to this object. So we're given this angle right here. There's the angle of depression. That angle, it says, is 34 degrees. There's our angle depression. Angle from between the horizontal and the line of sight. So we've got a visual. Now what are we looking for? What we're trying to find is the distance that object is from the base of the cliff. Here's our unknown, x. So we want to find x, right? So to do that, all right, think about what we have in front of us. We have a right triangle. We have a cliff here that's vertical to the ground, right? It says this object is level with the base of the cliff. There's a 90-degree angle there. The vertical and horizontal make 90 degrees. We have a right triangle. We can see our picture of our right triangle that we're looking at. We got one of the legs is 40 meters in length. The other leg is x. What we need to go ahead and do while we're at it, let's go ahead and find, all right, the other angles. Now we know that this angle here would also be 34 degrees. Let's talk about the angle of elevation. Alternate interior angles are always congruent. So we draw that in. Now if you wanted to find the third angle, we could. We know that third angle is going to be what? 180 minus the sum of those two, 90 plus 34, which is what? 124. 90 plus 34. And then 180 minus 124, as we look at that, is 56 degrees, right? Which would be this angle here. If you wanted to label it, we know that would be 56 degrees. So you can add all three of those up, and we're going to get 180 degrees. So again, using a little bit of geometry, we can label in the rest of it. Now with that said, we know what? We want to find x. So let's use our given information. I'm going to use that 34-degree angle. All right, let's use our trig function. Let's use tangent. We know that the tangent of 34 degrees would equal 40 divided by x. Opposite over hypotenuse, right? So again, I'm drawing in a picture. Get a visual, what we're looking for. Now we're ready to solve that. So let's go ahead and solve x. So to do that, I'm going to go ahead and clear out my fraction. Multiply both sides by x. And as I do that, I got x times the tangent of 34 degrees equal to 40. And then all I got to do is divide out my coefficient. Let's solve the linear equation now. Get x by itself, divide out the tan of 34 degrees on both sides, and we'll have what we're looking for. The distance the object is from the base of the cliff. That's what we've labeled x here. So 40 divided by the tangent of 34 degrees. So let's go ahead and plug that in. So get your calculator out. I'm going to go ahead and do this one with you. Let's pull up our TI. So as we go in here, we got 40 divided by the tangent of 34 degrees. So I got 59.3. 59.3. So x is 59.3 meters. Said round to the nearest tenth. So there's our distance. There's our unknown. Distance the object is from the base of the cliff. So again, using tangent definition, right, we're able to solve that. Now let's go ahead and look at example B. Let's do another one. Application here using angle of elevation or angle depression. Aerial photography. It says an aerial photographer who photographs farm properties for a real estate company has determined from experience that the best photo is taken at a height of 475 feet and a distance of 850 feet from the farmhouse to the plane. What is the angle depression from the plane to the house, round the nearest degree? So now we're trying to find the angle depression. So in the last problem, they gave us the angle depression. We're going to find it in this one. So let's get a picture. Go ahead and get a visual of what we're looking at. So I'm going to go ahead and draw in here in this problem. I'm going to draw in a picture of this plane. Let's put our plane up here. Here's our plane flying here in the sky. And we're looking at photography. We're trying to take a photo of this farmhouse. All right, so I'm going to draw this farmhouse down here. All right, here's my farmhouse. And it says the best photo was taken at a height of, 475 feet from the ground. So let's go ahead and draw in the ground this farmhouse is sitting on. And let's draw in our height. We know this distance here is 475 feet. And it says the distance from the plane to the house. Let's draw that distance in. To the plane to the house. That will be 850 feet. Be his distance. Now we see, of course, we've got a right triangle. What we're looking for is the angle of depression. So I'm going to draw that in. Now remember, the angle depression is the angle formed between the horizontal and your line of sight down below. So here's my horizontal. Go ahead and draw that in. And here's my line of sight. So we're looking for this angle measurement right here. Now I'm going to go ahead, while we have it, let's go ahead and move this distance here, right here beneath it, 850 feet. But here's my angle of depression, right? I want to find, we'll call that theta. I'm going to get theta. Now, with that said, that's the angle of depression. And we know from geometry, we know that this is also theta, right? This will be the same. So this is our angle of elevation. Angle of elevation, always congruent to the angle of depression, right? Those are alternate interior angles. So we got to find theta. With that said, what can we use trig function-wise to get that? Right? We got theta here. Well, we want to involve the opposite side and the hypotenuse. So to find theta, I'm going to use my sine function definition. All right. So I'm going to use sine. So what's the sine of angle theta? 475 divided by 850. Opposite over hypotenuse. Now with that said, we're going to have to use inverses. We're going to have to use inverse characteristic because we want theta. So we've got to swap it out, interchange it. So theta is equal to sine inverse of 475 over 850. So we're ready to type that in. Let's go to our calculator. And we need to hit the second button, then sine, to get sine inverse. 475 divided by 850. We're in degree mode, 33.9. So nearest degree, 34 degrees. Rounding to the nearest degree, the nearest whole number. So there's our angle of depression, or angle of elevation, however you're looking at it. Looking from the plane down to the farmhouse, that's the angle of depression. If you're standing at the farmhouse looking up the plane, that's the angle of elevation. So yeah, we found theta. So there's some good applications using right triangles, right? Finding our unknown. So I hope that helps you and get you a good grasp on our right triangle trig that we've been spending time with here in the first two sections.